Graphs of polynomial functions. Graphs of polynomial functions with odd degree progress through opposite corners of the Cartesian plane. This implies that the curve must pass through the x-axis at least once. This means that odd degree polynomials have at least one real zero since polynomials are continuous, so there's no gaps or breaks. The polynomial equation p of x equals 0, where the degree of p of x is odd, has at least one real root, or one real zero. So in this instance, we can use the word root or zero interchangeably. Even degree polynomial functions do not necessarily cross the x-axis. Hence, they may have no real zeros. Let's have a look at an example. Let p of x equal x squared plus 1. Now, the graph of p of x is a concave up parabola with the vertex at 0, 1. And here's a sketch of that parabola. Solving p of x equals 0, in other words, x squared plus 1 equals 0, x squared is equal to negative 1, and therefore x is equal to plus or minus the square root of negative 1. Or for those that are considering extension 2, we could replace the square root of negative 1 with the pronumeral I. And this is not a real zero. So therefore, here's an example, or by example, we can show that there's at least one case of an even degree polynomial that does not have a real zero.